Hi, my name is Ross, and in this video I'm going to go over what you need to know before you start a physics experiment with a simple pendulum as our example. Make sure you stay to the end to go over how you can perform this experiment almost anywhere with little to no cost at all. Welcome to Experiments First with Ross. Our goal here at Tutor to Learn is to provide you with tangible examples and relevant exercises with which to learn math and physics. Let us know in the comments below which math or physics topics you're currently struggling with or you'd like to know more about. Let's get to it. Let's begin with the goal of an experiment. An experiment is a set of procedures where you manipulate one or more controllable variables and then you measure the effects they have on other dependent variables. And the idea is that you're trying to gain insight into how things work and the mechanisms involved. Just to be clear, a variable is any quantity that can be changed or fixed constant as desired. For instance, consider this simple pendulum. It consists of a mass fixed at the end of a string which is attached to a pivot point. It can be a string or a rod. The time it takes this pendulum to swing back and forth is called its period. And this period can be measured once you displace the mass from its resting point or equilibrium point and let it go. This height that it's raised to is dependent on the length of the string as well as the angle you displace it. Experimental design is the creative process of determining which quantities to control and which effects to measure. So in this video, we're going to be discussing what to control and then what we will do first as we measure the period of a pendulum to see what matters as it swings back and forth. And we have a couple options here, and we'll discuss all of that as we need. This creative process continues by deciding how to test the relationships between all of the quantities involved in generating mechanisms or models that accurately explain and predict reality. We begin this with a hypothesis, a very specific prediction that is testable such that the experimental results, when analyzed, can be used to explain reality and to really compare different models. The goal of the different analyses is to determine how to refine our experiments and to develop insight into the physical mechanisms at work. Let's review an abridged version of the scientific method. 1. Have some amount of experience observing the world around you. 2. Formulate a hypothesis or specific question regarding a mechanism or process for how some aspect of reality works. 3. Design an experiment to test the specific predictions about reality. 4. Perform said experiment and record the results. 5. Evaluate your results and determine how to improve the experiment based on those results and what they implicate about reality. 6. Collaborate with others to validate or confirm these findings. 7. Repeat. So you have something about reality you're interested in. You determine something that you can answer or you can try to answer. You go ahead and test this. You look at the implications, what's going on. You see if other people can reproduce it, and then you try to improve it and answer new questions as they come up. Now that we know what an experiment is and we have a clear methodology for learning about the world around us, let's practice by concentrating on a simple pendulum experiment to learn the fundamentals necessary for studying the physics of music, tides, quantum mechanics, and signal processing. I'd like to take a moment to clarify that this video won't prepare you for high-level mathematics and the theory required for the aforementioned topics. This video is meant to provide an alternative perspective for lifelong learners who think physics experiments belong in the classroom, as well as those of you who have some coursework or lab work to finish. The goal of studying a simplified system and model is to develop the intuition and background necessary to study and develop more complex systems. Before we get into the actual setup that I'm going to discuss using at home versus lab equipment, I want to take a moment and discuss a fundamental philosophical concept in physics and mathematics, and that is what is called perturbation theory. So the premise of perturbation theory is that almost every phenomena can be modeled as a deviation or perturbation from a simpler state or a simpler case of this phenomena. So for instance, a simple pendulum has a stable equilibrium right here at the bottom, and it won't move from that spot if nothing else changes, right? So when I displace the pendulum from this equilibrium state, I'm adding energy, gravitational energy in this case, and when it's released, the pendulum can swing back and forth or oscillate. Let's note that this pendulum is fixed to move in a circular arc, and due to the nature of the way I've tied everything, this one actually might start rotating in addition. That has a different name. It's still a pendulum, and so it still behaves and has a lot of the same underlying characteristics. So just keep that in mind. The big picture concept in physics a lot of the time is that you have some sort of equilibrium or simple state or case, and you cause some sort of, or something causes some sort of deviation or perturbation, and that allows or enables the system to oscillate, or just that you can describe the system as that perturbation or deviation from the base state or equilibrium state. In the next video, I'll cover more of the details about this phenomena of a simple harmonic motion, but for now, let's focus on learning the scientific method. So let's go ahead and pause the video and think of some of the other examples of quantities or phenomena that oscillate or move back and forth about some equilibrium state or like simple state. And while you're at it, make a list of which parameters of this pendulum system we can control, manipulate, and what aspects of the motion of that pendulum we would want to measure after we release it and let the motion happen. Now that you're back, let's move on to step 2 of the scientific method, and the last step in this video before we move on to the experimental design side of the scientific method, and that is formulate a hypothesis or a specific question that you want to investigate. I want to investigate how the time it takes the mass to swing back and forth, is called the period, is affected by the length of the period of the pendulum, the mass at the end, and the angle of displacement or the amplitude of the period of the pendulum. So let's make 3 separate hypotheses regarding the 3 different variables I just suggested. My 3 hypotheses are: 1, the period of the pendulum will increase as the amplitude angle increases for all angles. 2, the period of the pendulum will decrease linearly as the mass attached to the end increases. And 3, the period of the pendulum will increase linearly as the length of the pendulum increases. So see how those are all very specific? I want to investigate how this time to swing back and forth, or the period, is affected as an individual parameter is changed. So that's the length of the pendulum, the angle or amplitude, and then the mass itself that's fixed to the pendulum. All right, so before we move on to that bonus content and get you started on your own experiments, let's summarize what's been discussed so far. And that is to prepare for your experiment by making sure you're able to design it. So 1, you need some experience observing this phenomena that you're investigating, and you want to learn more about it. 2, you have to make sure you think about and formulate a hypothesis. This is a very specific question that you're going to try to answer through your investigation. So because science is a collaborative process, I hope you'll be able to join me as we to compare experimental results. So for this experiment with the simple pendulum, I'm going to choose to start with hypothesis 3, and that is to only vary the length of the pendulum. So remember that you should do your best to fix all the other values and only vary or change one at a time as you test these hypotheses. So let's go ahead and go over that. So in addition to the equipment I can use at work to, do the same sort of experiment, I'm going to go over how to do this at home. And so here you need some sort of protractor or ruler with angles. And so you need to make sure you can read what's going on there. And usually the biggest thing is you want to have this pivot be really tightly tied, and that way you can know exactly where to measure your angle from. So, just use a little mass, maybe 50 grams, 100 grams. It depends on what sort of thread or string you're using. I would go ahead and start with fixing your angle at like 15 degrees, 20 degrees, something that's, while relatively small, significant enough that you can easily read it with your device. And then typically we vary the length from like 25 centimeters to 100 centimeters or a meter. And that's just to give us a good range when we're varying this quantity, the length of the pendulum. And make sure that, when you go to do your experiment, you read your angle, you lift it up, and when you let go, you time it. And then you want to, keep in mind that you keep track of the time. So when you let go of it, it's there and back is 1. That's a period. And so because your reaction time might be pretty significant compared to the time for 1, try to have a setup where you can, where it doesn't damp too much, it doesn't diminish too much, and you can get like 5 oscillations out of it. Even 3 or 4 would be great. If you had a really good system, you could maybe get away with like 8 or 10. So try to time it for 5 or so, and then divide the time you get by the number of oscillations. So remember, when you let it go, it's there and back is 1, 2, 3. So that's going to be sort of the setup here I have. I have these little, just loops. You can put a ring. I literally tied it to a ring in this little, it's a little socket wrench head. You can tie knots and then use a ring. Anything that has just enough mass that the string is taut, but it's not really extending it too much or you're causing it to really come apart, will work. So, I can get really sophisticated results by what I can use at work, but let's go ahead and just reiterate what you can use at home. So remember, you need to measure length, mass, and angle, as well as that time. So mass, if you have a scale, use it. Whatever you got, go ahead and use. If not, try to make sure you're picking stuff that's clearly lighter and heavier than each other, and that way you can just sort of rank them lightest to heaviest, or least mass to most mass. And then you're going to have to measure that length. So you'll need some sort of ruler or a meter stick, a yardstick will work, and try to be consistent. And so because we're trying to gear up for math and physics courses, as well as engineering, we're going to focus with SI units like centimeters, meters, kilograms, seconds for time. We're going to use degrees for angles for now, just because that's usually what's on the protractors. So think about, what sort of thread or string do you have? Do you have hooks or arms? Like I have a light stand because I have this little ball joint head to move my light around. You can use your phone as a timer. Depending on what you have, just use what you have. That's all there is to it. Now I know what some of you are probably thinking. Ross, I don't have a light stand. I have different equipment than you. I have different materials. And I think that's really great that we all have this different equipment, different materials. We might live in different climates, because that's going to give us a really big perspective, or a much greater perspective of what really is involved with this type of phenomena. And that because we, can do our best to control these things, what we've chosen, right? How our manipulations differ is going to give us even more insight into things like friction, possibly air resistance, temperature, humidity, and that'll allow us to really investigate what matters when we're studying a phenomena, and especially when we're investigating very specifically how one quantity is affected, how the period or time of this pendulum is affected by different quantities, different parameters. In the next video, we'll discuss the specific design and methodology I used to do this experiment at home, my first set of results, and some tips to prepare you for a deeper dive on the data analysis. And then in future videos, we're going to go over improvements, second set of results, and then probably results from equipment I used at work to really give you a sense of, really well-made equipment versus what you can do at home. So don't forget to subscribe and click on that bell icon if you want to be notified when the next video is released. We hope to see you there so we can collaborate together and keep this process going. We hope you join our community of lifelong learners and join us to collaborate on the next video. So make sure you leave a comment below if you have your own results ready to report, as well as any comments about math or physics topics you're interested in, and even more importantly, any topics you're currently struggling with. I'm Ross here at Chew to Learn, and thank you for joining me for our series, Experiments First. Stay safe.